My name is Chawla and this is my submission for the Digital Assignment 1 for the course Natural Language Processing. The topic that I have chosen for the assignment is Application of NLP in Real-Time Machine Translation. What is machine translation? It is the automated process of translating text or speech from one language to another using computation techniques and algorithms. It aims to bridge language barriers by enabling communication between people who speak different languages. Rather than relying on human translators, machine translation uses computer programs to analyze and transform text from the source language into the target language. The goal is to produce translations that are understandable and convey the intended meaning, though the quality can vary based on the methods and technologies employed. Machine translation using NLP is a complex and fascinating real-time application that has revolutionized how people communicate across language barriers. This process involves the use of advanced algorithms and techniques to translate text or speech from one language to another in real time or near real time. Let us now take a look at the key steps involved in real time machine translation using NLP. The first step is text preprocessing. The first step involves preprocessing the input text. This involves tasks like tokenization, removing punctuation, and lowercasing the text. This step prepares the input for further processing. The second step is the language identification. In real-time scenarios, the language of the input text might not always be known in advance. Language identification is used to determine the source language before proceeding with translation. NLP models or statistical models can be employed to accurately identify the language. The next step is tokenization and embedding. The preprocessed text is tokenized into words or sub-word units. Each token is then transformed into a numerical vector using word embeddings or sub-word embeddings. These embeddings capture semantic relationships between words, allowing the model to understand the context of the text. The next step is neural machine translation model. NLP models are the cornerstone of real-time translation. These models use deep neural networks to learn the mappings between source and target languages. Encoder-decoder architectures such as the transformer model are commonly used for the NLP. The encoder processes the source language tokens and generates a fixed dimensional representation called the context vector. The decoder then generates the translation from this context vector. The next step is the attention mechanism. The attention mechanism is a vital component inside the NMT. It allows the model to focus on different parts of the source text while generating the translation. This is crucial for capturing long-range dependencies and improving translation quality. Decoding strategies involves the model generating the target language translation. Different decoding strategies like greedy decoding, beam search, and nucleus sampling can be used to improve the quality and diversity of generated translations. The real-time constraints involving in optimizing NMT model for speed without significantly sacrificing translation quality. Techniques like model quantization, model pruning, and efficient attention mechanisms are used to accelerate the translation process. Parallelization and hardware acceleration further improve the speed of translation. The NMT model can be parallelized across multiple GPUs or other hardware accelerators. This enables the model to process multiple input sentences concurrently. Once a translation is generated, post-processing steps like de-tokenization, capitalization, and punctuation addition are applied to finalize the translated output. The final step of the machine translation involves continuous learning and adaptation. Real-time machine translation systems can benefit from continuous learning and adaptation. User feedback and corrections can be used to update and fine-tune the model over time, leading to better translation for specific domains or contexts. Now let us take a look at a case study involving Google Neural Machine Translation, also known as GNMT. One of the prominent examples of NLP in machine translation is the Google Neural Machine Translation System, which was introduced by Google in 2016. GNMT is a neural machine translation system that significantly improved the quality of translations and set new benchmarks in the field of machine translation. Before the introduction of GNMT, statistical machine translation (SMT) systems were widely used, relying on linguistic rules and statistical models to translate text. These systems often struggled with capturing complex linguistic nuances and context, resulting in translations that were not always fluent or accurate. The introduction of GNMT had a profound impact on the quality of machine translation. Google reported that GNMT reduced translation errors by 55 to 85% on various language pairs compared to their previous SMT system. The translations produced by GNMT were often more fluent, natural sounding, and contextually accurate. GNMT's success also paved the way for the widespread adoption of neural machine translation architectures across the industry. It demonstrated the potential of deep learning and NLP techniques in tackling complex linguistic challenges and bridging language barriers. Features of GNMT: the neural network architecture in the GNMT replaced the traditional phrase-based SMT with an end-to-end neural network architecture, specifically the transformer model. This architecture allowed for better capturing of long-range dependencies and context in the source text. Attention mechanisms. One of the most important features of GNMT was its attention mechanism. This mechanism allowed the model to focus on different parts of the source sentence while generating the translation, resulting in more coherent and contextually accurate translation. Joint training. GNMT trained its model jointly on multiple language pairs. This shared training approach improved the translation quality for low resources languages, as the model could leverage the knowledge gained from other language pairs to improve translation for language with less available training data. Large scale training. Google had access to a massive amount of parallel text data from the vast collection of documents and web pages. This enabled GNMT to be trained on a huge corpus of data, which contributed to its impressive translation capabilities. Transfer learning and fine tuning. GNMT employed transfer learning techniques. This model was pre-trained on a large dataset and then fine-tuned on domain-specific or user-specific data. This allowed the system to adapt to specific contexts or industries, improving translation quality for those cases. Limitation and future developments of GNMT. While GNMT represented a significant leap in machine translation quality, it still faced challenges in handling certain language pairs, idiomatic expressions, and preserving certain linguistic nuances. Subsequent research and developments have continued to address the limitation and refine translation quality further. In conclusion, the Google Neural Machine Translation System serves as a notable case study of how NLP techniques, particularly neural networks and attention mechanisms, can be leveraged to revolutionize machine translation and provide more accurate and natural translation across languages. That's the end of my presentation. I thank you very much for watching it to the end.